Hello, this is Matt from Matt Heaney Apps, and welcome to part 3 in our 6-part full game tutorial series teaching you how to make the full iPhone game Solo Mission in Xcode using SpriteKit and Swift. So far we have a ship that the player can drag left or right, which fires bullets at enemies in space. However, at the moment the bullets just go straight through the enemies, and if the enemy hits the ship, it just moves straight through it. So today we are setting up our contacts, so the bullet can hit an enemy and the enemy can hit a player. We will also add some explosions to our game for when we kill an enemy or when an enemy kills us. So by the end of this video your game will look like this. So let's jump back into Xcode to continue. Okay, so back into Xcode and back into our game scene. Now today we want to set our game up, so if a bullet hits an enemy ship, the enemy ship will be destroyed. And when an enemy ship hits the player ship and the enemy ship will both be destroyed because they've crashed into each other, which will eventually be one of the ways this game can end. To do this, we will set up physics bodies around our bullets, our enemy ships and our player ship, and then set up contacts between these physics bodies. Now a contact between physics bodies is when two certain physics bodies overlap, effectively touching each other. Once this has happened, we will be alerted through our code and we can do something. So basically, with our physics bodies, we can say when two certain objects, whether that be a bullet and an enemy ship, or the enemy ship and the player ship, hit each other, do something. Okay? And that would be to either kill the enemy or kill the enemy and kill the player. We will also add an explosion to this to make it look good. So the first thing we have to do is set our scene up to be prepared for these contacts between physics bodies. To do this, we're going to find our SK scene right at the top of our game scene. We'll say comma, and we're going to say SK physics contact delegate. This here will let us use the code for when two physics bodies make contact, so when two objects touch. And also, to set this up, we will move into our did move to view, and we will say self.physicsworld.contactDelegate equals self. Now with this and with this, we can now use physics contacts in this scene. So the first thing we want to do is add physics bodies to our three different kind of objects: the player ship, the enemy ship, and the bullet. So let's find our player ship in our did move to view. And we will say player.physicsBody is going to be an SK physics body, and this will be the same size as the player. So rectangle of size with the size player.size. So our player now has a physics body. Because of this, our player will now be affected by forces such as gravity, which we don't want. So we're going to say don't let this player be affected by gravity because we don't want it being pulled down the screen. So player.physicsBody, so affects the physics body of the player. We have to force unwrap this, so exclamation mark. Dot affected by gravity is false. So our player now has a physics body, but it will not be affected by gravity. We'll do the same thing for our enemy ship. So into spawn enemy. Before we add it, we will say enemy.physicsBody equals SK physicsBody, rectangle of size. So it's going to be a rectangle of enemy.size. And again, do not be affected by gravity. So affected by gravity equals false. So our enemy now has a physics body. And then finally with the bullet. So bullet.physicsBody, again SK physicsBody, rectangle of size, because all three of these objects are pretty close to a rectangle shape. Normally you want to work with simple shapes for your physics bodies. So rectangle of size, bullet.size. So match the size of the bullet, and then say bullet.physicsBody affected by gravity is false. So now all three of our objects now have physics bodies, but we told each of them not to be affected by gravity because that's not how we want to use these physics bodies. We want them for contacts rather than forces such as gravity. So now that we have these physics bodies around these objects, we can move on to start dealing with them making contact with each other. Now, as I said, the contacts can be between a bullet and an enemy, and then we want one thing to happen, or between an enemy and a player, then we want another thing to happen. So because of this, we need to know which physics bodies are which. And also because of this, we only want certain physics bodies to interact with other physics bodies in certain ways. So for example, we don't want our bullet to interact at all with our player. So what we'll do now is set up physics categories for each of these physics bodies. We'll then assign each of these bodies into a category, and then we will say only let this physics body interact with certain physics bodies in certain ways. So for example, the bullet will completely ignore the player, but it can interact with the enemy. Okay, so we set this up so it can only interact, therefore make contact with the enemy. That'll make sense as we go. So first things first, we will set up our physics categories. So what we're going to do, we'll do this in a struct, so in a structure. So we will say struct, and we will call this physics categories. And now in here, we can set up all of our physics categories. Now, even though we have 3 objects, we actually have 4 categories. We have 1 category for our player, 1 for our bullet, 1 for the enemy, and we also want 1 for none. Because when we set up our physics bodies, not only can our physics bodies make contact with each other, they can also collide with each other. And this would mean, say for example, if 2 objects hit each other, they would just bounce off of each other. So don't run any extra code, just collide into each other and bounce off. So for example, if the bullet hit the enemy, it will kind of knock the enemy out of the way. So we're going to use none to tell all of our physics bodies not to collide with anything because we're only dealing with contact. Okay, so in here, what we're going to do, we'll set up our 4 categories and each will have a number associated to it. Now this will do all the work behind the scenes and then we can just work with the name, making things a lot easier. Now this number is going to be a form of binary, but don't worry, not as scary as it sounds. So let's set up our 4 categories. We will say static let, and the first name is going to be none. The type of this will be an unsigned integer, 32-bit, so uint32, and this is going to equal the binary form for 0, which is just 0. So we now have a category called none, which is going to be represented by a number of 0. Our second one is going to be the player, so player, again, uint32, and this will be 1, which is 0b1. So this is just a form of binary for 1. You can add a quick note to yourself of 1. The next one is going to be bullet, which is going to be the binary form for 2. And our final category is static let for enemy, again, uint32. This one will be 4 because 3 would actually represent the player and the bullet because it's 1 and 2. 1 and 2 is 3, so 3 would mean both of these here. So we'll set this to 4. So we now have our 4 categories: none, player, bullet, and enemy. We'll now use these to assign each of our physics bodies into categories, and then we can use them to only let certain physics bodies interact with other physics bodies in certain ways. So, one step at a time. Let's find our player and we will assign this into a category. So player.physicsbody.category bitmask. So what category is the physics body of the player in? And this is in the player category. So physics categories.player. So we've now assigned the physics body of the player into the category called player. For the bullet, we will say physics body.category bitmask equals physics categories.bullet. So we have now assigned the physics body of the bullet into the category for bullet. And for the enemy, enemy.physicsbody.category bitmask equals physics categories.enemy. So again, take the physics body of the enemy and put this into the category that we have called enemy. So we have now declared 4 different types of physics categories and we've assigned our physics bodies into a category. Now using these categories, we can now tell each body what to make contact with and what to collide with. As you may remember, we don't want any bodies to collide with anything because we're only dealing with contact. So when things start to touch, we can run some code. So we'll stay at the enemy. We will say enemy.physicsbody dot collision bit mask, and because we don't want the physics body of the enemy to collide with anything, we will set this to physics categories dot none. We do, however, want our enemy to make contact with the player and with the bullet. So enemy dot physics body dot contact test bit mask equals. So here we're going to say what we want the physics body of the enemy to make contact with. So what can the enemy touch? Now we want to know when it touches the bullet and the player. So we're going to say physics category dot player or physics category dot bullet. So now if the physics body around the enemy makes contact with a physics body in the category of player or in the category of bullet, let us know. So basically, if the enemy hits a player or the bullet, let us know. Okay, so into our bullet, and we can do the same sort of thing. So we're going to say bullet.physicsbody.collision bitmask, and again, because we don't want any collisions, it's going to be physics categories dot none. But the bullet can make contact with the enemy. So bullet.physicsbody contact test bitmask equals physics category dot enemy. So now the bullet can make contact with the enemy, so the bullet can hit the enemy. So we will now be told when the bullet hits the enemy. Okay, because the enemy is in that category, we can now be told. And finally, for the player, again, it's going to be collision bitmask of none, and the player can hit the enemy. So contact test bitmask equals physics category dot enemy. Because remember, when the player and the enemy hit, both will be destroyed, which is one of the ways the game can end. Okay, so now this is our physics bodies all set up. To quickly recap, we gave all three of these objects physics bodies. So our player, our bullet, and our enemies physics bodies. So a body around the object. We then assigned each of the bodies to a category, whether that be player, enemy, or bullet. Using these categories, we then said how these physics bodies can interact with other physics bodies. So we told all of them not to collide with anything, okay, because we're only working with contacts. We then told each of these physics bodies what they can make contact with. So the player's physics body can make contact with any physics bodies in the enemy category. And the enemy's physics body was in this category, so the player can make contact with the enemy. Same with the enemy. We put it into a category. We said don't collide into anything, but tell us when you've made contact with any physics bodies in the player category or in the bullet category. Okay, and then the bullet, we also assigned into a category of bullet. We said don't collide with anything and let us know when that physics body has made contact, so when it's hit the enemy. So our physics bodies are now all set up, and now the correct physics bodies are interacting, so in this case making contact with the correct physics bodies. So now this is set up, we can do something when two objects have made contact, whether that be the bullet hitting the enemy or the enemy hitting the player. So when two physics bodies that can make contact actually do make contact, so actually hit each other, what happens? Well, a function called didBeginContact will run. So just like how didMoveToView is going to run as soon as we move to the scene, didBeginContact is going to run when a contact has been made. So let's add, outside of another function, our didBeginContact function. So now this here is going to run when two physics bodies that can make contact have made contact. Okay, so if the bullet hits an enemy, this will run, or if an enemy hits the player, then again this will run. And when this runs, we're being passed contact, which is a kind of SK physics contact. Now contact here holds all the information about the contact that has just been made. So contact holds the information about which two physics bodies have made contact. And these are called contact.body.A and contact.body.B. Okay, so the two bodies that have made contact are being passed to us in here as body A and body B. Our job is now to figure out which two physics bodies these were, and therefore if the bullet has hit an enemy or if an enemy has hit the player, and then do the right thing. Because different things will happen. If a bullet hits an enemy, we want to delete the bullet and run an explosion on the enemy. We will also in the future want to add a point to our score. If the player and the enemy hit, however, we want to run an explosion on both of them and then run game over again in the future. So we want to run different code depending on which two types of physics bodies have made contact, whether that be the bullet and the enemy or the enemy and the player. The only problem is, when we're being passed contact, we can be passed anything in any order. So taking the bullet and the enemy for example, contact.body A could be the bullet and body B could be the enemy, or it could be the other way around. So body A, the enemy, and body B, the bullet. So what we want to do, we want to organise these so we can easily check to see which they are. And basically we're going to organise these in numerical order depending on their category number. So you remember these guys from up here, these numbers? We're going to say order these two that are in a contact into the numerical order so it'll be a lot easier to tell which two physics bodies have made contact. Because otherwise we've got to say if body A is this and body B is this, or, and then flip that, and it's just a mess. So we're going to organise contact.body A and contact.body B so it'd be a lot cleaner to see what has made contact with what. To do this, we're going to say var body1 is going to be an SK physics body, and var body2, again an SK physics body. So we will now organise body A and body B in numerical order to body 1 and body 2. Okay, when it's in place, it'll make more sense, I promise. So we're going to say if contact.body A, so the first body in the contact, and we're going to grab the category of bit mask, so the number associated with the category bit mask, whether that be 0, 1, 2 or 4. Okay, so this number here. So we're going to say if this is less than contact.body B's category bit mask number, then what we're going to do, we're going to say body 1 equals contact.body A and body 2 equals contact.body B. So if this isn't the case, we're going to flip this round. So now body 1 is going to equal contact.body B and body 2 is going to equal contact.body A. Okay, let's break this down. We're saying grab the category number of body A and the category number of body B. Now if body A's category number is less than body B's category number, then they're already in numerical order. Body A has a lower category number than body B. So it's body 1 is body A, body 2 is body B. If this is not the case, however, and if body B has a lower category number than body A, then they're not already in numerical order. So take body 1 and set that to be body B and body 2 to body A. So basically, after all of this, we now know when we get a contact, whichever body has the lower category number, so whether that's 1, 2 or 4, assign this to body 1. Okay, so whichever one has the lowest category number, assign it to body 1, and whichever one has the higher category number, set that to body 2. So for example, if the enemy now hits a bullet, because bullet's category number is 2 and enemy's category number is 4, body 1 will always be bullet and body 2 will always be enemy. Okay, so they're numerical order. Okay, body 1, body 2. Same with the player and the enemy. Player will now always be body 1, enemy will always be body 2 because they're in numerical order. So, with this, it's now really quick and really easy to see which objects have made contact. We're going to say if body 1, so the body with the lowest category number, if body 1.category bitmask, if this is the player, so if body 1 is the player, and body2.category.bitmask, if this is the enemy, let me close the side, then do the following. So now this means if the player and the enemy have hit each other, do the following. So this here is if the player has hit the enemy. Okay, so now this if statement is really easy because we've organised our two bodies that were in the contact into numerical order into body 1 and body 2. Now the other possible contact is if body1.category.bitmask is the bullet, so physics category.bullet, and body2.category.bitmask is again the enemy. Okay, so now if the bullet has hit the enemy, if the bullet has hit the enemy. Okay, so now in here we're going to have all of our code for if the player hits the enemy, and in here we're going to have all of our code for if the bullet has hit the enemy. Now in just a few moments we will deal with our explosions, and we'll also add to these when we do our score system and our game over system. But for now, let's do the most basic thing we have to do in each of these. So if the player hits the enemy, we want to delete the player and the enemy. So we will say body1. We'll take the node. This will be an optional. I'll explain why in just 1 second. And we want to delete it, so remove from parent. So find body1, find the node associated with that physics body and delete it. Same with body2. And for now, actually, for the bullet and the enemy, we want the exact same thing. So if a bullet hits an enemy, delete the bullet and the enemy. So body1, take the node associated to it and remove it, and delete the enemy. Okay, so body1 is the bullet, delete the bullet, and body2 is the enemy and delete the enemy. Now these are optionals because body1 or body2 or any of these bodies might not actually have a node. So this could happen in theory, for example, if two bullets hit one enemy at exactly the same time. In that case, the code would try to delete the enemy twice, and if this wasn't an optional, it would crash out. So this is avoiding a potential glitch that will crash the game. So in a minute, we're going to spawn our explosions, but for now, we're going to test this out. Because now, if a player hits an enemy, then both will be deleted, and if a bullet hits an enemy, again, they will both be deleted. And that's because our physics bodies are in the right categories and can make contact with the correct physics bodies that are in other categories. Okay, so let's hit run and let's check it out. So here is our game so far. Now if you hit an enemy with a bullet, the enemy and the bullet will both delete. If I can actually hit an enemy with a bullet. And if an enemy hits the player will be deleted. At the moment, even after the player's ship has been destroyed, you can still fire bullets, but don't worry about that. That will not be the case when we set up game over. All we have to do now is make this look awesome with an explosion, and we have one small glitch to fix. So we'll start with that first, I think. So let's jump back into Xcode. Okay, so this potential glitch is to do with when the bullet hits the enemy. Now remember, when the enemy spawns, it actually spawns off the top of the screen. So it's to give the illusion that it is moving onto the screen. However, at the moment, our bullet can hit the enemy when it's not even on the screen yet. Now at the moment, you won't really be able to notice that, but when we have our score system in place, you probably will be able to notice this. What we're going to do is only run the code for if a bullet hits an enemy if the enemy is on the screen. Okay, so we're going to add an extra rule to this second if statement. So we're going to say if the bullet hits the enemy and the enemy is on the screen, then do the following. So don't do the following if the enemy is not on the screen. So, and for an extra rule, body2.node.position.y, so where it is up and down the screen, if this is less than the height of the scene, So self.size.height. That will then mean the enemy is on the screen, so then we can kill it. So if it's not yet on the screen, don't do the following and just pretend that the bullet has not hit the enemy because the enemy is not yet on the screen. So only do this if the enemy is on the screen. So with that potential glitch now out of the way, we can move on to dealing with our explosions. Okay, so for the explosion, what we're going to do is use the image explosion to add a bit of an effect to our ship or to our player once it has been destroyed. What we will do is spawn this image in the game scene in the position of the ship that we want to destroy and run some actions on this to make it look like the ship has exploded. So in the game scene, what we'll do just after the did begin contact is say func spawn explosion. So in this function, we will deal with the explosion. Now for this, we will be passed some information and we will be passed spawn position, which is going to be a CG point. Now to run this function, we have to pass it a position on the screen. And we're doing this because we want this explosion to spawn in the same position of an object that has been deleted. So later on, when we run this function, we will pass it the position that we want this explosion to spawn in. So here, we will treat this explosion just like a normal sprite node. We'll say we call it explosion. It'll be an SK sprite node, and it will use the image that is called explosion. We will set this starting position to be the position that we're going to pass this function. We will give it a Z position of 3, so it will be on top of the ship, whether that's the player ship or the enemy ship, even though very quickly after this has spawned, the ship will be deleted. And we will add this. We'll do some more to this in a second to make it look like an actual explosion. But before we do that, let's worry about spawning this. So we want to spawn an explosion when we either remove an enemy ship or the player ship. Okay, so back up into our did begin contact, and we will start with if the player hits the enemy. So before we remove it, what we want to do is tell that function to run with the position of one of these ships. So we're going to run it twice. First time with the position of the player, second time with the position of the enemy. So we will say spawn explosion in the position of the player, which is body 1. So body 1 dot node. Now as we have to pass information to this function to run, we have to force unwrap it dot position. So run spawn explosion after passing it the position of body 1, which is the player. So pass it the position of the player. Now spawn explosion will run, and it will spawn our explosion, and as it's getting past spawn position, we're going to use that information that we've gathered in this function and use that as the position of the explosion. Okay, so anything we pass as spawn position, we're going to use as the position of the explosion. Okay, so when we run it, we're passing it where to spawn. Same thing with body 2, because in this case, it's the enemy. So the player hits the enemy, we want them both to explode. In our other if statement, we only want body 2 to explode. We don't want the bullet to explode. Okay, so remember body 1 is the bullet, body 2 is the enemy. So we're going to say spawn explosion of body 2 dot node dot position. Okay, we're now getting explosion in the position of the ship that we want to explode. Whether that be the player, which is body 1 in this if statement, or the enemy, which is body 2 in this if statement, or the enemy in this if statement, if it hits the bullet, which again is body 2. So we have now passed our function a position to spawn in. But here we've had to use an exclamation mark to force unwrap a node, which pretty much says there's guaranteed to be a node here, because to run this, we have to pass it this information. But earlier on, I mentioned that this has to be an optional, meaning there might not be a node because it might have been deleted previously if, for example, 2 bullets hit 1 ship at the same time. So this kind of goes against what I said earlier, that there might not be a node, because I've now said here there's definitely going to be a node and we're definitely going to pass it information. Now if the thing that I mentioned happens, where if 2 bullets hit 1 ship, for example, and there's not a node, therefore there's no position, therefore there's no information here, which will cause our game to crash. But this can't be an optional. We can't say there might not be a node because we have to pass information. So to work around this, what we're going to do is only say this if there is a node. So if something happens and 2 objects hit one thing at once, we don't want our game to crash. So we want to say only do this if there is a node there, which the vast majority of the time will be the case. But if on the rare occasion something like this happens, we don't want it to crash. So what we would do, around where we call each of these functions, we will say if player1.node doesn't equal nil, then do the following. So if body1's object isn't nothing, so if there is an object, then do this. Okay, so now potential problem avoided. This will only run if there is an object. So if it isn't nothing, so now if 2 bullets hit 1 ship at once, for example, our game won't crash. So this is just a bit of safety. So we're only saying do the following if there's actually an object. So again for the other one, if body2 in this case, we're running body2.node again doesn't equal nil, then do the following, because we can definitely pass information down because there's definitely a node, and therefore we can pass the information down and therefore our game won't crash. And same in our other if statement for if the bullet and the enemy hit. If body2, because we're dealing with the node of body2.node doesn't equal nil, so doesn't equal nothing, so there is something there, then do the following. So now we can spawn our explosion without the worry about this potential crashing problem. So now we can run our function, passing it where to spawn. So we now have an explosion. We can now use some actions to make it look more like an explosion rather than just an image. Okay, so to do this, we will use some actions. And basically, what we want the image of the explosion to do is start very, very, very small, scale in, and then fade out. So to start with, before we add our explosion, we will set the scale to 0. So it's very, very, very small, we can't see it. It's so small, there's nothing there. We'll begin by making it get bigger. So let scale in, it's an SK action, and it's scale to 1, scale to normal size from nothing, so get bigger, with a duration of 0.1. Very, very quick. Let fade out equals SK action dot fade out with duration. Make sure this is out and not in. Again over 0.1 seconds. We also want an action to delete our explosion once it's faded out. So let delete SK action dot remove from parent. We now want these to run in an order. Let explosion sequence, it's an SK action dot sequence. So this will be a list of actions that will run in order. So we want it to scale in, so get bigger, then fade out. So scale in, then fade out, and then delete. So now we can say explosion, our sprite node from up here, dot run action explosion sequence. So now explosion will spawn with a scale of 0, so it will be scaled to nothing, and then it will scale in. Once it's scaled up, we will fade it out, so fade out to being invisible, and then delete it. So now we have an explosion that will work, and it will look like an explosion. For mine, I'm going to add a little bit extra with a sound effect. Now, just like our first sound effect, I can't give you this sound effect because I don't own it. I've just paid to use it in this video. So either use your own sound effect or just leave this sound effect bit out. That's why I'm doing it separately right at the end. So, explosion sound effect. So my sound effect is here on my desktop. So let's drag it in. make sure copy items if needed is ticked, because this will make a copy of your sound effect in your project folder, and hit finish. To set up our sound effect, we will do this globally, because remember, this way we don't get a little bit of lag the first time it plays. So let explosion sound, an sk action dot play sound file named, and we want to play the sound explosion sound effect dot wav. So explosion sound effect dot wav. Wait for completion is false, because we want the next action in the sequence to start straight away. And then we can just slip it straight into our sequence. So spawn explosion, and then straight away explosion sound. So now when we get an explosion, we're going to get a sound effect, and then our image will look like an explosion. And just like that, we now have our explosion set up. So now if a bullet hits an enemy, spawn an explosion in the position of the enemy. Or if our player and the enemy hit each other, spawn 2 explosions, one in the position of the player and one in the position of the enemy. So let's hit run and let's check it out. As you can now see, if a bullet hits an enemy or the enemy hits the player, we get our explosion. So we now have our contact set up. So we now have a game starting to come together, and you should hopefully be able to feel an almost working game. In the next video, we will set up a score system, a live system, and a level system, and by the end of the next video, your game will look like this. So as always, thank you for watching. If you liked watching this video, which I really hope you did, hit that like button, hit subscribe, leave any feedback down in the comments, and I will see you next time. Goodbye.